So first of all, you have to understand the word discrete. What is the meaning of discrete? That means countable, yes. Or you have individual value. A variable that has is countable or individual value. Correct? Okay, what do you mean by random? What do you mean by random? That means no specific order. You select without specific order. That's called random. Variable, you know, the value that can change. Okay? Can? So this is what we are going to discuss for this whole chapter. You hold on, let me finish up this part, then I answer your question. Okay? Can or not? Okay, so if you look at your chapter 7, you look at the opening problem. Can you please look at the opening problem in chapter 7, page 184. Okay. What is the variable that we want to talk about? What is the variable that we want to talk about in this opening problem? In a sideshow games, players have a 50% chance of winning the prize worth 2, 5, 10, or 20. Okay? The probability of winning this prize are given in the table below. So you see the variable is what? What is the variable that we are interested in? Price. Win in playing this game. I have shown the attendance code. You come in late. So next time, please come in early. Done? Okay. Prize win in playing this game. So what is the possible outcome? So I let this variable be X. Okay. Yeah. So what are the possible value of X? So every time when you see a problem, you must ask yourself, what are the possible value of X here? Is it just 2, 5, 10, and 20? 0 is also one of the possible value. In this question, they give you the table. So during exam, I can give you a table and I ask you to list out the possible value of X. Then I ask you to build the probability distribution table. I can give you this. Then I leave a space for you to fill in. All right? That is what is going to happen in the exam. And they say the probability to get 2, 5, 10, and see this one is 50%. And they give you the probability of getting each one. Okay, so now how to get this one? I know is 0. So the total probability of the 4 is 50%. We know that sum of probability must always be equal to 1. So this is when you talk about probability. So remember, the value of a probability is lowest is 0, highest is 1. This is some true fact that you have to know. When I have the probability of 0, what does that mean? It's never going to happen. If I have a probability of 1, definitely will happen. If I have a probability of 0.5, equal chance. If I have a probability of less than 0.5, unlikely to happen. If I have probability of 0.9, I say very likely to happen. So when you talk about probability, you are talking about likelihood. Understand? And you must remember this. You will never get a value more than 1 or less than 0. Are you clear? Okay, when I say things about probability, in another word, I'm talking about proportion. Okay? I also can translate it to percentage. So when I talk about percentage or when I talk about proportion, I'm talking about the population. Okay? So are you clear? So this is the problem statement. From there, I translate. So every time you have to define your variable. You have to know what are the possible value of your variable. You see, all these possible value is individual value. That's why we call this a discrete variable. Are you clear? Can I have 2.5? Can. It's individual value. So other than countable, you have to be individual value, also considered as discrete. You get me? Okay, so now, what is the sum of the probability on the table? I told you it must be 1. So this is the true fact. Okay, why must this be the answer? Can someone answer me? Why must this be the answer? Yes? The question said, what is the sum of the probability in the table? Sum of the probability is equal to 1. Then they ask why. You cannot say like that. You didn't answer why. Because these are all the possible outcomes. So for all these possible outcomes to happen, the chances is what? Hello? You cannot say I ate up. Why must I'm asking you, why must all the probability end up be equal to 1? Because these are all the possible outcomes for this variable x that we define. So the chances for all these variables to happen is 1. So definitely will happen. If you don't want to say the chances is 1, you say this definitely will happen. Any one of them will appear. Clear? Okay. So now that means if I put it mathematically, it will be probability So are you okay? So I can also write this as such a way, probability of, if I say probability of all the variable to happen, this is probability of x equal to 0 or 2 or 5 or 10 or 20. This is use all. When you use all, you add up all the probability. So this is something that I want you to remember when I use all. So the probability for each, and they are independent variable. What do you mean by independent variable? That means it will not depend on others. If I draw 2, I cannot draw 0. That's it. If I got the price of 2, can I get the price of 0? There's no intersection at all. You still remember in your high school you learn about Venn diagram? Yeah. So this is the one, everyone is individual by itself. There is no overlap. Okay, so I'm trying to recall all your okay. So done with that. Okay, what is the most likely outcome for playing this game? When I say most likely outcome, I'm looking for the mode. Okay, which is the most likely outcome? Didn't get any prize, because that is the highest probability. Am I right? So part B, it will be 0. X equal to 0. Okay, then part C. Okay, what is the average? So average, what you do? Okay, how do we count average? Let me explain to you first. How do we count average? Sum of xi, I equal to 1 to 5, because I got 5 values here, divide by 5. No, cannot divide by 5, because I'm not talking about the number of data. I'm talking about sum of, sorry, I have to put pi here. It's like frequency. Okay, sum of pi. I equal to 1 to 5. Okay, what is the value of sum of pi? 1. So that means indirectly, if they give you anything about probability, you take the probability like the frequency. So it will be equal to sum of xi pi. So this is the formula to find the mean. Why I don't have to divide? Because sum of pi is equal to 1. Okay, so you can just use your calculator, multiply and add. If you don't want, what can you do? If you don't want to multiply and add up, what can you do? You can use your GC, correct? You can use your GC. Okay, everyone take out your GC and try to do it. So manual calculation will be 0 times 0.5 plus 2 times 0.35 plus 5 times 0.1 plus 10 times 0.04 plus 20 times 0.01. Okay, so tell me what is the answer? $1.8. So can I move on? Okay, so you get it from your GC, you also get 1.8, correct? Yeah. So how do you interpret this? How do you interpret this 1.80? Okay, this one you get from your GC, the mean is 1.8. How about the standard deviation? Can you tell me? Only this one show up, am I right? Only this one show up, am I right? So that show is population, I told you already. Okay, what is a standard deviation? 2.94, very high. The spread of the data from the mean is very high because we have the highest value of X is 20. The mean is 1.8. Correct? The lowest is 0. So you see the spread of the data is very big, very far away from the mean. Am I right? The average. Am I right? That's why you have such a high standard deviation. Okay, now how do you interpret the mean? Yeah, expected. What do you expect? You are playing the games. What you are playing this game. So what are you expecting from here? That means every time when I play this game, I expect to win $1.8. That is called mean. Can you please write down? How do I interpret this value? Every time when I play this game, I expect to get $1.8. Every time a player play this game, the owner of the store expect to pay this owner $1.8. Expect to pay to the player. Okay, so the question asked, what is fair price for playing the game? Fair, that means fair to both sides. So how much the store owner must charge for a person to play this game? $2, that means I play the games. Every time I play, I lose 20 cents, you know not? Is it fair? No. In order for it to be fair game, the amount you receive, the amount you won must be the same as the amount you paid. That is only called fair game. In the long run, no one win, no one lose. Are you clear? So what is the fair price for playing this game? $1.8. If the store owner charge $2, that means it's an unfair game to the player. If the store owner charge $1.5, is unfair to the owner. Are you clear? So that's why we want to count expected. So in the long run, as you play many games, sometimes you may win, sometimes you may lose. In the long run, you're expected to win $1.8. So the store owner should charge you $1.8 in order for the game to be a fair game. Are you clear? Can or not? That means indirectly, you are expected to gain 0 from playing this game. Gain means your expected money you win minus the money you pay. That is called gain. Are you clear? Profit. Profit is what? Revenue minus cost. Your revenue is the money that you win. The cost is the money that you pay to the store owner for playing this game. Hello? So in order for a game to be fair, the profit must be zero. Or the amount you gain must be zero. Are you clear? So is it okay? So that is the reason why we want to count mean, expected outcome. I expect to have that at the end of the day. Or in the long run, when I play this game over and over again. For playing this game, I expect to get 1.8. I expect to win 1.8. Okay? Can or not? Okay, good. Can I? Variable. Okay, what are the possible value for X? What are the possible value for X? Huh? 0 to 80. Infinity. How can rainfall to infinity? You think Noah Ark time? No, they have the gauge, then they follow by how many cm. They collect the rain. Yeah, they go by cm. Or millimeter. How many millimeter you think? The worst rainfall that we have, 15 mm. You look at the last year, correct, in Malaysia. Huh? Still remember? We have very, very terrible flood in here, and also in Shah Alam, until the water go up to the rooftop. So these are the possible values. So it can go right up to 1 or 2 meters. So we don't know. So, but if you say infinity, I disagree. But generally, you will go right up to 20 cm is a lot already. Okay? Are you okay? So if go up to 1 meter, that is under dangerous level already. Okay? But it's possible. It's possible. So these are called all the possible value of X. So you don't say infinity in this case. So maybe you say 1 meter. This is my judgment. All right? Or 2 meter, maybe. Yeah. Okay, give possible value of the random variable. Okay, so I have done all that. This is part 3. That is question 2. Okay? As long as you have the word measurable, usually it's a continuous variable. Yep. Like the stopping distance of the tire also is a continuous variable. Okay, that one you can refer to the book. This one you must have your experience. Yep. Okay, so to check the reliability of a new tire of a light switch as the repeated turn on and off until they fail. Okay, so this, for this case, I will say the number of, for this particular question 2 part C, correct? I will say the way they state the variable is not very good. I will say the number of switch that will fail after how many times of turn on and off. Because if you say turn on and off, how many times am I supposed to turn? Okay. Or you say the switch will fail after maybe you put the turn on and off 10 times, 20 times, 30 times. So your variable will be number of times that you turn on and off the switch. That will be a discrete variable. Okay, so part C of the question for question 2 is not a very good way of stating a variable. Okay, okay, let's go to part 3, question 3. Okay, let's go to question 3. Okay, Suppose the spinner alongside are spun and X is the sum of the number. Okay, now you look at here, we got the two spinner. So two spinner, we are talking about the sum. Anything, if you have two things done together and you are talking about the sum or whatsoever, what we need to do is, I will draw a table like that and I will put, this is spinner A. And spinner A got this outcome 1, 2, 3, and 4. This one is spinner B. And I have 1, 2, 3, 4, 5, 6. So I'm talking about my variable is the sum of the number shown by this two spinner. Right? Am I right? So what are the possible value for X here? Can you tell me? 2 to 10. How you know 2 to 10? This is 2. Sum of the two biggest value is 10. 2, 3, 4, 5, 6, until the last one is 10. So it's a discrete random variable. Am I right? So now if I build a probability distribution table, I'm doing more than what the question is asking. I'm teaching you how to do table. Like just now they give you the probability, correct? So I write down my variable X. I have 2, 3, 4, 5, 6, 7, 8. Oh, I don't have enough. 9. Can I just put down here? And the last one, 10. Right? Okay, now how am I going to count the probability? Okay, in your high school, you got use a tree diagram, but I will prefer to use this chart, it's easier. So how many outcomes will I get? How many possible outcomes for this situation? The first spinner, I have 4 possible outcomes. And the second spinner, I got 6 possible outcomes. So in total, I have 4 times 6, 24 possible outcomes. Do you know how I get the possible outcome? So every 1 year, the probability will be over 24. So 2 only appear once. 3 appear twice. Agree? 4 appear 3 times. 5 appear 4 times. You see how nice this table is to show you? And 6 also appear 4 times. Am I right? 7 appear also 4 times. Also 4 times. 8 3 times. 9 twice. And 10 once. 24, sorry. So you see, I built the probability distribution table. So explain why X is a discrete variable, because it is the sum of a discrete number. Okay, state the possible value of X, we have done that. And we do extra step. Can you count the expected outcome? What is the expected value for X? If I write that, means expected value for X, which means you have to get the mean. Are you okay? Can you please key into the calculator, or you just use this formula? Since I didn't ask for standard deviation. And do you know I'm teaching you 7B also already? Do you know I'm teaching you 7B already? I teach you how to build the probability distribution table. And I'm teaching you 7C already also. And for this question, correct, I can translate in such a way that the sum you get will be the price that you will win, the amount of money that you will win. So from there, okay, how much should I charge for the game? I can put it like that. The sum of the two numbers shown by the spinner will be the amount of money that you will win for playing this game. So then I can ask you how much I should charge you. Hello? XIPI lah, why you have to over P? Yeah lah, sum of PI is equal to what? Yeah. Okay? So what do you get? 6. Right? So then I will say, oh, in order to be a fair game, okay, then I also can change the question. Okay, if the store owner, okay, want to have a profit of 2 ringgit, $2. So how much must he charge for playing each game? $8. So you see or not, that is how we use expected value to determine how much profit you want. A simple game like that. So insurance company, correct? They tell you, insurance, I insure you this. Oh, so at the end, if something happened to you, you'll get this. Actually, they have counted it. Okay, the chances of this person to get this is very low. So they know what is the expected payout. Like expected payout to a customer is 200. So do you know they charge the premium? They want the profit of 100. They charge the premium of 300. And they always sell like that. They always sell like that. You only pay 300. But if anything happened to you, you can claim so much. If I know statistic, what will I say? What is the chances I will get sick? You tell me. You show me the data. So why I still buy, like for me, why I still buy medical insurance? Why I still buy medical insurance? I pay this amount of money, a small amount of money, to transfer my risk to the insurance company. So I don't have to take the risk. If what happened to me, like